Okay, so today we're going to graph cubed root functions, and the parent function looks like this. F of x equals the cubed root of x. And we are going to graph it. So in order to graph it, let's make up a table. I'm going to make a table. Okay. I'm going to put in 8. Don't copy this down. I just want you to think with me, okay? Don't write this down. I'm going to give you a better table. Do you guys know what number multiplied by itself 8 times? Or what number multiplied by itself 3 times will give you 8? 2. Okay. So I know that if I plug in an 8 here, the answer is 2. Does that make sense?
Yes.
Okay. What if I plug in a 1? It'll just be 1. Okay. What if I plug in a 0? It'll just be 0. Okay. What if I plug in a -1 right here? And don't think in terms of I. What number multiplied by itself 3 times will give you a -1? -1, because -1 times -1 is +1 times another -1 would make this negative. Okay, so this is -1. What about -8? -2, because -2 times -2 is a +4 times another -2 would give me the -8. Okay, so I just wanted you to think with me. Let's rewrite this table so that it goes least to greatest. Okay, go ahead and write that down. You want to go least to greatest. So basically these are negatives and these are positives. So let me fix my table so that it's in order. Okay, so your table should look like that. Okay, and then just graph the points. So -8, -2, 1.
We're actually grabbing it.
Graph this. 1, 2, 3, 4, 5, 6, 7. -8, -2 is right here. -1, -1 is there. 0, 0 is there. 1, 1, 8, 2. 8, 2. Okay, so this is what the cubed root looks like. Okay, the reason why it looks like this, do you remember several units ago, we did, I'm just gonna do this in red, we did x cubed, and that looks like this. It's because they're inverses of each other. They're reflections across the line y equals x, okay? That's why it looked kind of horizontal. Okay, let's answer the questions on our page here. What is my domain? All real numbers, it's going forever to the left and forever to the right. So it just covers everything. Okay, what about my range? All real numbers, it goes forever down and forever up. So that will also be the same. Okay, so guys, where the point of inflection is basically right here, where it kind of changes shape. Right here to like that. That point is at 0, 0. You will see this point of inflection shift whenever you move left, right, up, or down. Okay, so for example, just as an example, you don't have to write this. Let's say I turned this into a -3 plus 2. What would happen to our graph? Yes, every single point would go to the right 3 up 2. So this point would move here and here. This point would move right 3 up 2. This point would move right 3 up 2. So it would look like this. So your new point of inflection is right there. Make sense? Okay. So point of inflection is how it moved left, right, up, or down. In behavior, as x goes to the left towards -infinity, what's happening to your graph? Yep, it's also going down to -infinity. So we'll write that. Okay, as I travel this way, to infinity, what's happening to the y values? Yep, also going to infinity. And we're not doing increasing value, decreasing value. All right, let's go ahead and move on to another part of our notes. Let's talk about transformations. Okay, so H is the what kind of shift? Good, horizontal. And if there's a plus sign, you know you're gonna go to the left, good. And if there's a minus, we go to the right. Y'all got it. K is the good vertical shift. And this one's straightforward. If you have a plus sign, it'll go up. And if you have a minus sign, it will go down. All right, your point of inflection is HK, how it moves left or right. And if A is negative, the function is reflecting across which axis? X-axis. Now, I heard someone say Y. Let me show you when it will be Y. Please write this off to the side. If I have a negative on the inside, this negative will make it reflect over the y-axis. But if it's on the outside, on the A, that will reflect across the x-axis. Okay, another thing I want you to add. Right here, I'm going to put the letter B. This B determines horizontal movement. So if it will be horizontal stretch or compress. And it's opposite of what occurs when it's on the outside. So if it's a stretch, that means the absolute value of B is less than 0 or between 0 and 1. And if it's a compress, it'll be greater than 1. So it's opposite of how it normally would be. Okay, so I'm just gonna catch y'all up. Most of you guys already finished this. This right here is a what? Vertical.
Vertical compression.
There we go. Vertical compression by 3/4. Now, guys, what if this 3/4, just think with me real quick. What if this 3/4 was on the inside? What would you say? Good. Thank you, Ethan. So it would be a horizontal stretch if it was on the inside and then you do the reciprocal 4/3. Make sense, guys? Okay, that's if the 3/4 was on the inside. But since it's on the outside, we'll just keep it like that.
Wait,
okay?
So what would 2 be? Would 2 be a stretch?
Oh, if I had a 2 on the inside here?
Wait, no, like number 2. Like what would number?
This is a vertical stretch by 5. How do you go from 1/4 to 1/2?
Wait, never mind.
This is a vertical stretch by 5. If the 5 was on the inside instead of being on the outside, we would call it a horizontal compress by 1/5. If that 5 was on the inside. Make sense, guys?
So
Okay.
just be the opposite.
Yeah, so basically, if it's on the inside, flip it and tell me what it would be.
Okay.
Okay. All right, so we did all the transformations. Let's go ahead and try to graph one of these. And this one is actually straightforward. Guys, what are the transformations on them? Yeah, left 3 up 2. I'm gonna make this a little more complicated. Guys, watch. I'm gonna make this a little more complicated. I don't want y'all to do this easy one. Rewrite this as so. Rewrite it like that. We're gonna make this a little harder.
For the what?
It's just
All right, guys, let's write down the transformations. Write this down somewhere near this graph. What does the 2 in the very front do? Yes, vertical stretch by 2. What does that mean we do? You're very close. Y's. The only thing that affects your X values are stuff on the inside. Okay? Only thing that affects the X values are what's on the inside. Okay, so this affects the Y value, the 2, and this goes up 2. These affect the Y values, okay? Now let's talk about what affects the X values, what's on the inside. So what does this negative do? Yes, reflect over the Y axis. And what is that plus 3? Left 3. Okay, so guys, normally, don't copy this down, but normally your parent function looks like this, right? We just graphed it. If it reflects across the x-axis, the y-axis, it will hop like this. It's gonna look like this. You see how this side mirrors this side mirrors that side. So your new graph is gonna be facing this way. A rough sketch is it's gonna face this way. Then it's gonna stretch out some, and it's gonna move to the left and go up. All right, so let's do an actual sketch of what this will look like. Okay, let's make the table. The parent table that I gave you in the beginning was -8, -1, 0, 1, 8. This was -2, -1, 0, 1, 2. This is the parent graph. The parent table. Now let's add the transformations to the Y values. What do I do first? Yes, so guys, multiply all the Y values by 2. And then you're going to add 2 to the Y values. So -2 times 2 is -4. And then I'm going to add 2 to get what? -2. Okay, so that stayed the same. -1 times 2 is +2. Multiply by 2 up 2, this becomes 2. 1 times 2 is 2, plus 2, this becomes 4. 2 times 2 is 4, plus 2, this becomes 6. Okay, so that's the transformations of your Y values. Now let's do the X values. It says reflect over the Y axis. What do I do to all these X's? Change the sign. So this will become positive, positive, negative, negative. And then it says left 3, so good, we subtract 3. So this will become 5. Subtract 3, this becomes what? Subtract 3, subtract 3, subtract 3. Okay, now we graph it. 5, -2. 1, 2, 3, 4, 5, -2. -2, 0. -3, 2. -4, 4. -11, 6. This is -11 right here, and then 6 there. Okay, so my graph looks like this. Now let's answer the questions. Domain and range, that's still all real numbers. Point of inflection, what do you think that will be? -3, 2, because it went left 3 and up 2. Your point of inflection is right here, this big one. Okay, so as X goes to the left, does Y go where? As we go this way, what's happening to the Y values? It goes up. Well, that's a little different than the parent function. As X goes to the right, what's happening to the Y's? It's going down. All right, that's it. We're not talking about that. Okay, so guys, that is how you graph them. I'm gonna do an example on how we solve for cubics. So you guys can do the rest of these. Let's solve one. So guys, the first step is you wanna isolate, right? What should I do first? Y'all got it, divide by 3.
Wait, where are we at? Oh. The other two?
So we have
No, sorry.
4. Okay, do you guys have an idea of how I get rid of a cubed root? Cubic, good, Emma. I'm gonna cube this side, I'm gonna cube this side. So I'm gonna cancel this out. I am left with 2x equals, what's 4 times 4 times 4? Y'all got it. And then you just divide by 2. So we get x is equal to what? Perfect. Okay, now we always need to plug it back in and make sure we don't get anything crazy. So here's the original problem. Let's make sure this is not extraneous. Something extra that they gave us. Shh, quiet please. All right, 3 cubed root of 64. What times what is 64? 4. Okay, so this becomes 4, and 3 times 4 is 12. Okay, so this is a solution. It worked. Make sure you plug your answers back in to make sure it makes sense. Okay, one more example, and I'm just gonna come out the dome with it. I'm not gonna give you a square root. I'll say 5x minus 2 to the 1/3 plus 7 equals 12. What do I do first? Subtract 7, good. So I get 5x minus 2. 12 minus 7 is 5. What do I do now? Divide by 5, good. I get all of this equals 1. How do I get rid of that 1/3? Yes, whoever said, was that you? Thank you, Everett. I'm gonna multiply this to the power of 3. Multiply this to the power of 3, because guys, look. Let me write this off to the side here. What's 1/3 times 3?
1.
Yep, I can change this to a fraction. 1 times 3 is 3. 3 times 1 is 3. That's just 1. So we're gonna multiply both sides by a cube. This cancels, I'm left with x minus 2 equals 1. Solve. X is 3. Now, make sure you plug that back in to make sure it makes sense. Do it on your own. Plug it back in and tell me if it makes sense. Guys, what can you rewrite a 1/3 as? Cubed root. To the power of 1/3 is the same thing as saying a cubed root, okay? So this problem can look like this. It's the same thing. It's the same thing, okay? A cubed root is the same thing as 1/3, okay? All right, plug it back in. Tell me if it makes sense or not. Yeah, it's off the dome. It came out of my brain and it worked out perfectly. All right, so y'all have confirmed that it makes sense. So this is not extraneous. X equals 3 is a solution. That's the end.